Okay, we're back on. So, we were about to do law of sine to do sine of b to what? 5.8. And the pair we now know is sine of 35 to 3.5. Okay, this should work. We should get our one answer that we need. If you calculate this, you'll get sine of b comes out to be about approximately 0.95. And so when you do inverse sine, b will come out to be 72 degrees. Sounds good, right?
No, because the sides don't match up.
Okay. So what would angle A be in this problem? Just, I got 72, I got 35, that's 107. So angle A would be left to be 73 degrees.
That wouldn't work.
That wouldn't work?
That wouldn't work. It would 3.7 have to be bigger than 5.8, right?
Angle B should be bigger than angle A?
Yeah.
Yeah, does that make sense? If I go fill in here that angle B is, we came out with angle B being 72 and we got A to be 73. That's got the largest angle, or the largest side opposite a smaller angle. Can that be? No. Okay, so that causes a wrinkle here. Why didn't we get the right answer? This is supposed to work. Well, the problem is, if one of your angles, if there's room for one of your angles to be obtuse, it has to be, when we were looking at this before we calculated this, if one of these was going to be obtuse, which one would have to be the obtuse angle? The largest one, which would have been B in this case. Okay, we calculated B first and got 72. So we assumed that was right. But it's the same old thing. It could have been 72 in the first quadrant, or it could have been 72 and it could have been an obtuse angle. How do you know? Well, the best thing, what you really need to do is you need to calculate the smallest angle first. You know it can't be obtuse. So you need to go calculate the smaller of the two angles that are left, find it, subtract, and then you'll get the larger one. If it's obtuse, it's obtuse. If it isn't, it isn't. So the key thing is, after the law of cosines, you must find the smallest remaining angle next. So once you're done with law of cosines, you got to go find whatever the smallest angle would be next, because then when you subtract, you'll find out if it's the obtuse angle or not. So now, the other way you can avoid that, if you don't want to do that, you can solve every problem all the way through with law of cosines. If you kept using law of cosines to find every single part,
So you can only use that once.
well, you can use it more, but you only need to use it once.
So how do you write the answer to this?
Okay, so in this one, you would not have done this. And this problem, once you got done after you did your law of cosines, you got your 3.5, you would have looked up here and at the side length, and you would have gone, which of these angles was actually going to be the smallest angle of the two that were left? Did A or B have to be the smaller angle? So you needed to find A next.
So if it says find B and we can't.
You just have to go find the other and then subtract and get B at the end. So you should have on this problem gone, oh, I'm going to find A next because it's the smallest angle. So I would have done sine of A to 3.7 and then the sine of 35 that we knew to 3.5. You would have found A first, which would have come out 37 degrees. So then how would you have found B? 37 and 35 up there are 72. So B would have come out to be 108 then. So you've always got to get the smallest thing first. Now, this is something that drives me crazy. When first few years I was teaching These work fine. Then I got a new book, new trig book, and I had some problems in it. We were doing law cosines. We did not, I had never seen this before myself, this little fluke in it. Most of the time it'll work right the first time. And I hit this problem that would not come out right with the right answers. And I had to do research in 3 or 4 books before I finally found where somebody did an explanation of this little situation. It doesn't happen often, but occasionally if you've got that obtuse angle in there, it's going to mess you up, and you have to find the smallest angle next. But it's not evidently very well known issue. Okay, I have one last question for you, and this is more an algebra question. If I give you a side-side angle, can you guys see the algebra you need to do to solve this? I should have drawn that with. It will. If they gave you all 3 sides, you know it makes a triangle. You know it's legit. I want to find C here. Angle C. My question is, can you do the algebra to solve your law cosine here? If I want you to find C, which version of the formula will you have to do? If I want you to find angle C, what letter has to be on this side? It has to be side C on this side if you're going to try to solve for angle C. This is an order of operations question. So in this case, C squared side C is 44, A is 56, B is 37. So I'm filling it in. Okay. Here's my question. How do you solve for angle C correctly and not mess up the algebra? Okay. You can work all these out if you want to work out every single number. I personally don't like to do that. You have to realize this stuff back here is all multiplied times cosine. So that's like some number times cosine. That's a coefficient on cosine. I'll have people who try to calculate all this from 56 to the end of this 37. They want to calculate this all and make one number. You can't do that. You've got to move it. If it was me, I would bring over, when I do it, I do minus 56 squared minus 37 squared. Then I divide over that stuff in front of cosine. That way you've got cosine by itself. Then you can chunk all that in your calculator at once. Thursday, yeah. All right. Enjoy your law of sines and cosines. You're using it every day for the rest of this chapter. There are lots of uses of the law of sines and cosines.